left thumb suddenly hurt, like, a lot. Chapter 13, Section 2, 8, Upper or Flinty Chalk. The upper chalk is characterized by its numerous parallel layers of flint. In this county, it constitutes by far the most considerable portion of the chalk formation, extending to the summits of the highest hills, and in some instances reaching nearly to their base. The chalk of this deposit is generally of a purer white, and of a softer texture than the inferior strata, but in other respects presents no sensible difference. It is regularly stratified, and partakes of the general inclination of the other divisions of the series. It is separated by horizontal layers of siliceous nodules into beds that vary from a few inches to several feet in thickness, and which, in some localities, are traversed by obliquely vertical veins of tabular flint that may be traced for many yards without interruption. These are sometimes disposed horizontally, and form a continuous layer of thin flint of very considerable extent. The nodular masses of flint are very irregular in form, and variable in magnitude, some of them scarcely exceeding the size of a bullet, while others are several feet in circumference. Although thickly distributed in horizontal beds or layers, they are never in contact with each other, but every nodule is completely surrounded by the chalk. Their external surface is composed of a white opaque crust, consisting of an intermixture of chalk and silex, probably formed by a combination of the outer surface of the nodule with its investing matrix, while the former was in a soft state. Internally, they are of various shades of gray, inclining to black, and often contain cavities lined with chalcedony and crystallized quartz. When first extracted from the quarry, flint is brittle, has a conchoidal fracture, and feeble luster. Thin fragments are translucent. Its specific gravity is 2.594. According to the analysis of Klaproth, it consists of silex 98, lime 0.5, alumne 0.25, oxide of iron 0.25, water 1. It is infusible, but upon being submitted to a great heat becomes white and opaque. By exposure to the atmosphere, it undergoes considerable change and assumes a yellow or ferruginous color, an appearance commonly exhibited by the flints of our plowed lands. When in contact with ochraceous clay or sand containing iron, it frequently attains a dark carnelian color externally, the interior being of a lighter shade. Of this kind, numerous beds occur in the parish of Barkham. Flints so commonly enclose the remains of sponges, alcyonia, and other zoophytes that some geologists are of opinion that the nucleus of every nodule was originally an organic body. That this has been the case in most instances is very evident. And in Sussex, there are comparatively but few flints that do not possess traces of zoophytical organization. These nodules oftentimes exhibit not only the outline of the original zoophyte, but also its internal structure, preserved in the most delicate and beautiful manner that can be conceived. In some examples, the zoophyte has undergone decomposition, and the space it occupied been partially filled with an infiltration of agate, chalcedony, and crystallized quartz. Although even in the present advanced state of chemical science, we are unacquainted with the process by which silex may be dissolved in water, yet that its solution was formerly effected by natural causes on a very extensive scale. The siliceous nodules, whose history is the subject of these remarks, afford the most conclusive evidence. At the present moment, nature in her secret laboratories is still carrying on a modification of the same operations, of which we have remarkable instances in the boiling springs of the geyser in Iceland and of Carlsbad in Bohemia. Nor is a high temperature absolutely essential to the solution of silex in water, since this earth occurs in a large proportion in the mineral waters of our own island, and also enters into the composition of the epidermis of various plants of the cane tribe, and of the English reeds and grasses. The epidermis of the Equisetum hyemale, or Dutch rush, consists almost entirely of silex. There is scarcely a single fact in geological science that has so much excited the attention of philosophers, or given rise to so many unsatisfactory conjectures, as the formation of the siliceous nodules of the chalk. Upon this interesting subject, which is still involved in much obscurity, I shall not presume to hazard an opinion, but content myself with offering a condensed view of those theories that have received the sanction of some of our most eminent geologists. The celebrated Werner, whose opinions are embraced by Professor Jameson, Mr. Parkinson, and others, offers the following explanation of the phenomenon in question. He supposes that, during the deposition of the chalk, air was evolved, which, in endeavoring to escape, formed irregular cavities that were afterwards filled up by infiltration with flint. The decomposition of the softer parts of the animals thus entombed may be considered as a probable source of part of the gaseous matter that formed these cavities, and the connection of the animal remains with those nodules of flint is easily explained by supposing the shells, crusts of echini, etc., to have projected into the hollows, or to have been adherent to their sides, at the period at which this infiltration took place. That the separation and disposition of the matter forming the nodules have been the effect of crystallization is rendered evident by the cavities left either in these nodules or in the fossils, being generally lined with quartz crystals. Upon this subject, Dr. Berger remarks that with regard to the formation of flints in chalk, if we adopt the theory of Werner, I should be as much disposed to attribute the void spaces in the chalk to a natural contraction of its substance as to the disengagement of air. We know that chalk divides, by drying, into compartments that are sometimes very regular, nearly in the same way as marl. According to this hypothesis, we may suppose either that the chalk and the flints are of contemporaneous formation, that the elements of flint were mixed with those of the chalk, and that they separated from each other by elective affinity, or that the siliceous matter has been afterwards introduced, and has filled up the cavities left in the chalk. Professor Buckland, whose opinions on geological subjects merit the highest consideration, objects altogether to the explanation offered by the Wernian theory. It does not, he remarks, appear possible that the flints could have been formed by infiltration into pre-existing cavities, like the regularly disseminated geodes of the trap rocks. Since this hypothesis, in the case of chalk, would imply the anomaly of their having once existed uniformly over many hundred square miles, as many strata of air bubbles as there are of flint, alternating with the chalk, and of which air holes not one was left empty or partially filled, whilst, on the other hand, many of the nodules could not have been formed in such air holes, as they entirely derive their shape from some extraneous bodies affording a nucleus to the silex that has encrusted them. He then offers the following ingenious theory as the result of a diligent investigation of the subject. Assuming that the mass which is now separated into beds of chalk and flint was, previously to its consolidation, a compound pulpy fluid, and that the organic bodies now enveloped in the strata were lodged in the matter of the rock, before the separation of its calcareous from its siliceous ingredients. He conceives that the bodies thus dispersed throughout the mass would afford nuclei, to which the flint, in separating from the chalk, would, upon the principle of chemical affinity, have a tendency to attach itself. The chalk and flint he considers to have proceeded through a contemporaneous process of consolidation, the separation of the siliceous from the calcareous ingredients having been modified by attractions, which drew to certain centers the particles of the siliceous nodules, as they were in the act of separation from the original compound mass. The distances of the siliceous strata he imagines to have been regulated by the intervals of precipitation of the matter from which they are derived, each new mass as it was discharged, forming a bed of pulpy fluid at the bottom of the then existing ocean, which being more recent than the bed produced by the last preceding precipitate, would rest upon it as a foundation similar in substance to itself, but of which the consolidation was sufficiently advanced to prevent the ingredients of the last deposit from penetrating or disturbing the productions of that which preceded it. That the beds of chalk and flint were deposited periodically cannot admit of the slightest doubt. Specimens are not unusual in which angular fragments of black flint, that could not possibly have been originally formed in their present state, are embedded in chalk. An example of this kind in my possession contains several portions of flint which are as sharp and translucent as if recently broken, and entirely destitute of the external opaque crust invariably seen in the perfect nodules. These are embedded in and separated from each other by the chalk. It is sufficiently obvious that the nodule from which these pieces were derived must have been displaced and broken, subsequently to its original formation, and the fragments afterwards enveloped in another and more recent stratum of chalk. But to return from this digression, the line of coast from Brighton to Beachy Head exposes an interesting vertical section of the upper chalk, exhibiting almost every variety of character hitherto remarked in the beds of that deposit. At Brighton, the cliffs are composed of an accumulation of diluvial substances, resting upon the solid chalk, which there constitutes the seashore, and continues to Rottingdean. From thence to Newhaven the cliffs are nearly perpendicular, and on the western side of the harbour rise into an irregular elevation called Castle Hill, the upper part of which is composed of numerous beds of the plastic clay formation, the lowermost 50 feet consisting of the flinty chalk. On the opposite side of the river a low mound of chalk, capped with a bed of plastic clay and farraginous breccia, appears at Chimpting Castle. Proceeding eastward towards the signal house near Seaford, the chalk rises to a considerable height, and forms a majestic line of cliffs from thence to the embouchure of Cuckmere River. From this place they extend eastward and terminate in the magnificent promontory of Beachy Head, which is nearly 600 feet above the level of the sea. Along this line of coast, ammonites of a large size, plagiostome, terebratulae, echinites, and other productions of the chalk may be obtained in considerable numbers. The sections in the interior of the country are entirely artificial. Of these, the following are the most interesting, that occur in the southeastern part of the county. Hollywell Quarry near Eastbourne contains echinites, plagiostome, inocerami, terebratulae, the remains of fishes, etc. Alfriston Chalk Pit, remarkable for crystallized carbonate of lime of considerable purity. Cliff Hills. The pits formed on the sides of this insulated portion of the chalk hills produce a great variety of fossil shells and zoophytes, the remains of fishes, and the vertebrae and bones of unknown animals. In some of these quarries, after a recent fall, the chalk presents a remarkable appearance. The newly exposed surface is of a brown color, and uniformly marked with fine vertical striae, giving to the mass a fibrous appearance. Small conical portions of the chalk sometimes partake of the same character, and I have specimens that closely resemble calcareous fossil wood. In every instance, however, this structure is confined to the surface and does not affect the interior of the chalk. In all probability, it has been produced by a subsidence of the strata, which caused them to slip over each other before they were entirely consolidated. South Street Pit near Lewes affords a fine section of the Flinty chalk, exceeding 200 feet in height. An irregular canal or dike, varying from 2 to 8 feet in diameter, traverses this quarry in an oblique direction. It was noticed many years since at the northern extremity of the pit, and subsequent falls of chalk have from time to time exposed its course towards the centre, from whence it now appears to proceed easterly. A section of it is still perceptible at an elevation of a few feet. In some parts this cavity was almost empty, and in others nearly filled by sand, clay, and ochre of a light chocolate color. This canal or dike has probably been formed by a subterranean current of water, the substances it contains being evidently alluvial. South Street Pit is also remarkable as being the only known locality of the detached octahedral sulphuret of iron. It contains the scales, teeth, etc. of fishes, and numerous shells and corals. Beddingham Pit is situated on the side of the Downs, about a mile distant from the village. In ascending the hill, the grey marl, lower chalk, and flinty chalk are passed over in succession. The pit is between 20 and 30 feet high, and consists of 1. Vegetable mould intermixed with chalk rubble, 1 foot. 2. Chalk rubble, 3 feet. 3. Flinty chalk, 20 feet. The chalk is stratified in horizontal beds from 2 to 4 feet thick, and these are separated in some instances by layers of flints, and in others by chalk rubble. Flints are also irregularly disposed throughout the mass. This spot is peculiarly interesting, from the circumstance of the strata having been rent asunder since their original deposition. Vertical fissures are everywhere observable, and these are partially filled with broken chalk and flint, cemented together by crystallized carbonate of lime, of a light amber color. The sides of the fissures are encrusted with the same substance, which has insinuated itself into the crevices of the surrounding chalk, and also occurs in irregular concretions in the cavities of the flints. The surface of these stalactical depositions of calcareous spar is frequently covered with delicate undulations, as if the water had been suddenly congealed while in a state of agitation. Piddinghoe. This pit lies on the roadside, near the village of the same name. It is remarkable for the purity and softness of the chalk, and for the numerous vertical and oblique veins of tabular flint, by which it is traversed. These veins are of a most extraordinary character, for although the flint retains its original form and situation, yet upon examination it is found to be cracked and shivered in every direction. The fractured flint falls to pieces upon being removed from the chalk, but in some instances it is held together by sulphuret of iron, forming a conglomerate of silex and pyrites, of a very singular appearance. The phenomenon here remarked is not, however, confined to this quarry, but may be observed in several chalk pits near Lewes and Brighton. Sir Henry Englefield was the first who directed the attention of geologists to this subject. In a paper read before the Linnean Society, he notices several beds of shattered flints, which occur in a chalk pit at Carisbrooke, in the Isle of Wight, and after describing their appearance and situation, proceeds to offer some conjectures upon the probable cause of their destruction. This he supposed might have been occasioned by some sudden shock or convulsion, which in an instant shivered the flints, though their resistance stopped the incipient motion, for the flints, though crushed, are not displaced, which must have been the case had the beds slid sensibly. Offham Pit is nearly 200 feet high, and exhibits a good section of the Sussex chalk. It contains the large fibrous bivalve, the fragments of which are so frequently met with in every locality, teeth and palates of fishes, and numerous zoophytes. It is the only locality near Lewes in which the marsupites have been discovered. South of this place, in a bank on the roadside, the chalk is covered by a bed of ochraceous clay, and where in contact with the latter, the chalk and flints are marked with regular stripes of yellow, bluish-grey, and brown. This singular appearance extends into the substance of the chalk, but does not penetrate beyond the external crust of the flints. Similar specimens sometimes occur in the pit in South Street. Clayton Pit. This locality produces inocerami, notuli, plagiostome, terebratulae, marsupites, etc. Falmer. An excavation made on the side of the road, leading from the village towards the farm of Mr. Moon, is particularly interesting from the evident proofs it exhibits of the changes the strata have suffered since their original deposition. The pit is about 20 feet high, and contains the following beds, beginning with the lowermost. 1. Chalk with horizontal layers of large flints, 6 feet. 2. Chalk, much broken, containing interspersed flints, 10 feet. 3. Ochraceous clay and flint pebbles, from 2 to 4 feet. From the upper part of the pit, several fissures of an irregular shape, and from 3 to 6 feet in diameter, extend through the broken chalk to the more solid beds beneath. Some of these cavities are of an inversely conical form, and others are nearly cylindrical. They are filled with ochraceous clay, rolled flints, and rounded masses of a conglomerate, consisting of pebbles and fragments of chalk, held together by a ferruginous cement. A portion of the pit in which sections of 3 of these wells occur is represented Tablet 4, Figure 3. An appearance somewhat analogous is observable on the north side of the chalk hill on which the church of St. John sub Castro in Lewes is situated. The broken chalk in Falmer Pit is in very small pieces, the angles of which are perfect, a proof that although minutely divided, it has not suffered by attrition. The sides of the valleys of the South Downs are universally composed of chalk, of a character precisely similar, an appearance which in all probability has resulted from the ruin of the chalk cliffs having accumulated in sloping taluses at their base. Brighton Pits. There are several chalk quarries in the vicinity of this celebrated watering place, but of these one only is particularly worthy of notice. The pit alluded to is situated near the church, and affords an excellent example of that fractured state of the chalk which has been previously mentioned. It is thus described by Sir H. Englefield. The upper part of this chalk is in separate masses, not perfectly rubble, but with all their tender angles sharp, exactly as if just broken to pieces to put into the lime kiln, and quite clean, nearly of a size, and almost without any chalk powder mixed with them. Some remarkable veins of shattered flints occur in this quarry. Preston. The quarry is extensive and lies immediately beneath the village. It formerly produced numerous remains of fishes, pallets, teeth, etc., but is now seldom worked. It is, however, deserving of attention on account of several thin veins of pure flint that fill up vertical fissures in the chalk, and which, to use the language of Sir H. Englefield, appear exactly as if the flint, not being quite hard when the fissures took place, had been squeezed out of the beds, and had run into the fissures as soft pitch would do. I do not mean that this was the case, but merely to describe the appearance. Stenning chalk pits. These produce belemnites, plagiostome, diancore, teeth, pallets, etc. The sulphuret of iron found in these quarries is of a very singular form, being cylindrical, with a small projection at both extremities. A specimen is represented in tablet 16, figure 16.